All right, today in Algebra 2, we're looking at 9.2 circles. Okay? So the essential question for this section, what are the geometric properties of a circle and how do they relate to algebraic representations of a circle? After this lesson, you should be able to write, graph, and apply the equation of a circle. So we want to look at deriving the equation of a circle. So it says, recall that a circle is a set of points that are a fixed distance called the radius from a fixed point. That fixed point is called the center. It is the cross section of a cone cut by a plane perpendicular to the cone's axis. So here we see that this is our cone. We have a plane, we're cutting it perpendicular to that cone's axis, okay? And so the cross section gives me a circle. Tells me this circle here is a set of all points that lie 3 units from the point 2, -1. So the point 2, -1 is our center. So 2, -1. 3 units from that. So if I go 3 units in each direction, I'm on the edge of the circle. Okay. So now the standard form of the equation of a circle, right? And you see that we could make this right triangle in here, but this is the point x comma y. So this, okay, the distance is the absolute value of x minus 2. The distance here, absolute value of y minus -1, because this is the point 2, -1. So the standard form of the equation of a circle with center hk and radius r is x minus h quantity squared plus y minus k quantity squared equals r squared. So first we're just going to write the equation of a circle given the center and the radius. Okay? So the radius for number 1 is 1.8 at the origin. At the origin, my formula is simply going to be x squared plus y squared equals r squared, because my h and my k are 0, 0, so I don't need those parentheses. So x squared plus y squared equals, so I want to take 1.8 and square that. And so 3.24. So that's the equation of that circle. Number 2, radius of 5, center at -4, 5. Remember that if I put it inside parentheses, it's always the opposite. So instead of saying x minus -4, I would say x plus 4, quantity squared, plus y, it's a 5, so opposite of positive 5, minus 5, quantity squared equals, my radius was 5, so I square that, 25. There's our equation. Number 3, the radius is the square root of 74. The center is at 2/3, -6. So x minus 2/3, quantity squared, plus y plus 6, quantity squared, equals, when I square the square root of 74, I'm just left with 74. Number 4, the radius is 3 square roots of 2. The center 0, -1. So 0, I don't need parentheses, x squared plus the y is at -1, so that's y plus 1, quantity squared equals, I need to square 3 square roots of 2. I want to square the whole thing. 3 squared gets me 9. Square root of 2 squared gets me 2. 9 times 2 is 18. Okay, so that's writing the equation of a circle. So now we're going to go the opposite direction. They're going to give me the equation, and we're going to find the center and the radius. So number 1, I have x plus 6, quantity squared, plus y squared equals 81. My center, the opposite of positive 6 is -6. Comma, I don't have parentheses, so that's the number 0. So my center is at -6, 0. I take the square root of this number to get my radius, so my radius is 9. Number 2, x minus 22 quantity squared plus y plus 8 quantity squared equals 41. So my center, this is negative 22, so that comes out positive 22. This is positive 8, comes out negative 8. So my center is at 22, negative 8. I take the square root of this. This is not a perfect square. I cannot do factor tree on it, so I simply say my radius is the square root of 41. Number 3, x squared plus y minus 12 quantity squared equals 20. My center, x squared, I don't have parentheses, so that's 0. Negative 12 comes out as positive 12, so my center is 0, 12. Take the square root of this. That is not a perfect square, but I can do factor tree. So 20 breaks down to 5 and 4. 4 breaks down to 2 and 2. I have a pair of 2's and a 5 left behind, so I say my radius is 2 square roots of 5. And now it says write the equation of each circle, then graph the circle, state the domain and the range. So radius of 7, center at the origin. So if I write the equation, that's x squared plus y squared equals 7 squared, 49. Okay. To graph this, I graph the center, so that's the origin, 0, 0. Now I want to do the radius, 7, in each direction, top, bottom, left, and right. So I'm going to count up 7, left 7 from my center, down 7 from the center, and finally right 7. Those 4 dots that I just made, I'm going to connect those with the circle. There's the graph of the circle. If I wanted to make sure that that was a perfect circle, I would use a compass to connect all of those. You're just going to make sure that you do not give me a square shape. Make sure that you have it round. So now we want to identify the domain and range of this circle. So remember, domain are x values. So my domain, so this is negative 7 out to positive 7. So my domain is from negative 7 to positive 7 included. My range, my y values, again, negative 7 to positive 7. So there's the domain and range. So now let's look at number 2. A radius of 2, center at 1, negative 2. So I plot the point over 1, down negative 2. That's my center. From that point, in every direction, I'm going to go out 2. So I'm going to go up 2, left 2, down 2, and right 2. And I'm going to connect those. I'm going to find my domain and my range. So the smallest x value, this is negative 1. The largest x value, this is 3. So my domain is from negative 1 to 3. My range, the smallest y value, is negative 4, 0. So 0 to negative, sorry, I need to put the negative 4 first, smallest one first. So negative 4 up to 0. Number 3, the radius is the square root of 3. The center is at the origin. So the center at the origin. So the square root of 3, that is not a nice whole number. That is approximately 1.7. So this is approximately 1.7. Go approximately 1.7 out in each direction. And again, make a circle. So my domain, I know it would be from negative square root of 3 to the square root of 3. My range, same thing, negative square root of 3 to the square root of 3. Number 4, the center is at negative 3, 5. The radius is 5 halves. So that's 2.5. So I'm going to go 2.5 in each direction. So up 2.5. So this is the point 7.5. I'm going to go right 2.5. So that is the point negative 1/2. Down 2.5. So that is the point 2.5. And then left 2.5. So that is the point, let's see, at 3, negative 5.5. A circle. The reason I wrote down those numbers was so I could find my domain and range. So my domain, the smallest x was negative 5.5. The biggest x was negative 1/2. My range, the smallest y was 2.5. The biggest y was 7.5. So now we're going to do the opposite. They're going to give me the graph of the circle, and we're going to write the equation. So two things I need to write the equation of a circle: center and radius. So first I'm going to find my center. So on this first one, that is the point 2, negative 1. So then I'm just going to count how far out in any direction. So I'm going to go to the right. 1, 2, 3, 4. So the radius is 4. So I write this equation: x minus 2 quantity squared plus y plus 1 quantity squared equals my radius 4 squared, 16. There's the equation. Number 2, the center is at the origin, 0, 0. My radius is 3. So my equation, x squared plus y squared equals 3 squared, 9. Number 3, my center is the point negative 2, 1. My radius, let's see, 1, 2, 3, 4, 5 is 5. So my equation, x plus 2 quantity squared plus y minus 1 quantity squared equals 5 squared, 25. All right. Next, we have use a circle to model a real-world situation. It tells me a city wants to honor hometown veterans with a new memorial statue in a local park. A grid map of the park shows the statue is centered inside a circular fence with a radius of 5. 2 spotlights are shown at points 2, 2 and 10, 8 on the map. They are the endpoints of a diameter of a circular fence. So number 1, or first one, A, what equation represents the graph of the fence on the grid map? So again, I need center and I need radius, okay? So I need the center and the radius. All I know is that this point and this point are my diameter if I connect those, right? Halfway across the diameter is the radius. So, is also halfway between, that's going to get me the center, right? So if I find the midpoint between 2, 2 and 10, 8, that's going to get me my center. So remember, midpoint, I add my x's, so 2 plus 10, and I cut in half. I add my y's, 2 plus 8, and I cut in half. So 2 plus 10 is 12, and then I have to cut it in half. 2 plus 8 is 10, cut in half. So the midpoint is the point 6, 5. So my center is at 6, 5. So now I have to find my radius, okay? So my radius is how far am I out from the center to any point on my circle. So if I know that this is the point 6, 5, I wanted to go straight down. I see this is the point 0, 0 right here, right? So I have gone down 5 units. So my radius is 5. So the equation, x minus 6 quantity squared plus y minus 5 quantity squared equals 25. So part B says an information kiosk is planned. One possible location is represented by the point 9, 1 on the map. Should the kiosk be here, or should it be moved so as to not interfere with the fence support? So the very first thing that I need to find out is the point 9, 1 on the circle? Is it on the outside of the circle or is it on the inside? This is my equation. So I'm going to put the point 9 in for x and the point 1 in for y into this equation and see what I get. So 9 minus 6 quantity squared plus, instead of y, I'm going to put 1 minus 5 quantity squared equals 25. And I'm just going to work this out. So 9 minus 6 is 3 squared. 1 minus 5, negative 4 squared equals 25. 3 squared is 9. Negative 4 squared is 16. So I get 25 equals 25. So the point 9, 1 is on the circle or on the fence in this case. We don't want the kiosk to be on the fence. So should we move the kiosk? Yes, we should move the kiosk so that it is not on the fence. We would want to move it inside of that. All right, now we're going to complete the square to find the center and radius of it. We're going to complete the square just like we did before, only now we have to complete the square twice, once for x and once for y. So it says rewrite the equation x squared plus y squared plus 4x minus 8y plus 4 equals 0 to show that it is the equation of a circle and identify the center and the radius. So the very first thing that I'm going to do is get this 4 to the other side. And I'm going to put my x's together and my y's together. So I'm going to say x squared plus 4x. I'm going to complete the square, so I'm going to put plus blank. Plus y squared minus 8y plus a blank equals, I'm going to subtract my 4, that 4, plus my 2 blanks. Remember, to complete the square, I take the number in front of my variable and I cut it in half, right? B divided by 2 quantity squared. So here, 4 divided by 2 is 2. 2 squared is 4. Add it to one side, I have to add it to the other. Now for the y, negative 8 cut in half is negative 4. Negative 4 squared is 16. Add it to both sides. So now I take x squared plus 4x plus 4. That's a perfect trinomial, right? So I write it as 1 quantity squared. It's this x, and then it's this number cut in half, right? So 4 cut in half, x plus 2 quantity squared. Plus, now I'm going to do the same thing. Y, negative 8 cut in half, minus 4 quantity squared equals negative 4 plus 4 is 0 plus 16. There's the equation of the circle. It says identify the center and the radius. So my center, positive 2 comes out as negative 2. Negative 4 comes out as positive 4. This is my radius squared, so the square root of 16 is 4. So the center, negative 2, 4. The radius, 4. So now we're going to solve a linear quadratic solution. So it says, what is the solution of the system of equations 3x minus y minus 5 equals 0 and x squared plus y squared minus 25 equals? So remember that to solve a system of equations, I can either do substitution or elimination. I have x squared and y squared, x and y. So elimination is not going to work. So I want to do substitution. So I'm going to take this linear equation and solve for one variable. I'm going to go ahead and solve for y. So I'm going to solve for y. So I'm going to subtract 3x from both sides. Then I have negative y equals negative 3x. And I'm going to subtract 5 from both sides. So actually, you know what? It's going to be easier, if I just move the y over, add y to both sides. So then I get y equals 3x minus 5. Now I'm going to substitute the 3x minus 5 over here for this y. So I'm going to put x squared plus, instead of y, 3x minus 5, quantity squared, minus 25 equals 0. So now I can solve this equation for x. So I have x squared plus, so 3x minus 5 quantity squared. Remember, that means 3x minus 5 times 3x minus 5. So I have to FOIL or do my shortcut. So remember the shortcut says the first term squared, so 3x, I have to square both of them, I get 9x squared. Multiply the two terms together and double it. So 3x times negative 5 is negative 15x. Doubled gets me negative 30x. And then the last term squared, negative 5 squared plus 25. And then minus 25 equals 0. I'm going to combine like terms. So I get 10x squared minus 30x, so 25's cancel, equals 0. I need to solve this, so what do they both have in common? I can pull a 10x out, and then I'm left with x minus 3 equals 0. So I get x equals 0, x equals 3. So now I need to check these answers. I have two ways. I can plug them both into the original equations and make sure that they work, or I can graph them. So first, if I take x equals 0, so 3 times 0 minus y minus 5 equals 0. So then I would get negative y minus 5 equals 0, or y equals negative 5. So that tells me that the point, so I'm looking, is the point 0, negative 5 on the circle. So if I plug that in, okay, I get 0 squared plus negative 5 squared. So I'm at 0 plus 25 minus 25 equals 0. So yes, that one works. So now I want to do the 3. So I'm going to plug the 3 in. So again, 3 times 3 minus y minus 5 equals 0. So I get 9 minus y minus 5 equals 0. 9 minus 5, so 4 minus y equals 0. So y equals 4. So I would get the point 3, 4. If I plug that in here, 3 squared is 9. 4 squared is 16. Minus 25 equals 0. 9 plus 16 is 25. 25 minus 25. Yes, those are both on the circle. So both of those are solutions to the system. If I wanted to solve it by graphing, I'm going to graph both of these. So first I would graph y equals 3x minus 5. So my y-intercept is negative 5. My slope is, let's say, 3x. So up 3 over 1. And I'm just going to keep going at up 3 over 1 until I run off my graph. And then I'm going to go down 3 over 1. And so this is the line. So now I need to graph the equation of this circle. So my center is at 0, 0. The radius is 5. So 0, 0, 5. Here, and I'll switch colors for us. So the circle. So up 5 over 5. And then I'm going to draw that circle. And so where do they intersect? At this point and at this point. So this is the point 0, negative 5. This is the point 1, 2, 3, 1, 2, 4. Which is exactly what we got here. 0, negative 5, and 3, 4. Right, so that is the end of 9.2 notes, are circles. Your homework will be the 9.2 worksheet.